Let's solve a problem on conditional probability using the Bayes theorem. Of all people applying for a certain job, 75% are qualified and 25% are not. The personnel manager claims that she approves qualified people 85% of the time. She approves an unqualified person 20% of the time. What we want to find are two probabilities. A person is qualified if she was approved by the manager, and a person is unqualified if she was not approved by the manager. Okay, the first thing that we need to do is make sure that we know what probabilities the problem gives us and what probabilities it asks us for. Okay, 75% of the people are qualified. This is clear. This means that 0.75 is the probability for a person to be qualified out of the entire sample, and 25% of them are not. So 0.25 are not qualified. This means the probability is 0.25. Then we also know that the manager approves qualified people 85% of the time. What does this mean? This means that we have a probability of 0.85 for a person to be approved if it is qualified. So given that it is qualified. So it is the conditional probability of the event approved given the event qualified. We also know that the probability of being approved given that the person is non-qualified is 0.2, so 20%. These are the four probabilities that we know. What we don't know is what is the probability for a person to be qualified given that he has been approved, and what is the probability for a person to be non-qualified given that is approved. In order to solve this problem, and especially since we already know two conditional probabilities right here, we have to use the Bayes theorem. The Bayes theorem is the theorem that you see on the right of the screen. Okay, how do we do that? The first thing that we need to do is to set up a binary tree. Always on the first level of the binary tree, we are putting the probabilities for the event that we are looking for. Not the given event, but the event that comes first on the conditional probability. So the event that we're looking the probability for. While the second level of the binary tree will always be the probabilities for the event that is given. So here we have the given, and here we have the unknown. Okay, on each branch of the binary tree, we have to put the probabilities. So we know that the probability for a person to be qualified is 0.75%. So this is 0.75. The probability for a person to be non-qualified is the rest, 0.25%. The probability to be approved given that is qualified, so this part of the branch, is 0.85. The probability to be approved given that is not qualified, it's 0.2. So this branch right here has probability 0.2. So basically what we know, if you look right here, is the first branch and the third branch. For this and for this, we have probabilities. this is equal to 0.6575, and this is equal to 0.6875. Now, if you look again at your screen, you will realize that this branch is nothing else than this part and this part of the Bayes theorem, while this branch is equal to this part of the Bayes theorem. Okay, so we apply the Bayes theorem and we have at the top 0.6375, and at the denominator we have 0.6375 plus 0.6875. The result for that is equal to 0.927. What is this? What you just found right here is the probability for a person to be qualified given that it is approved. 0.927. Now we are looking for the probability for a person to be non-qualified given that it is approved. That the answer for this question will be 1 minus what we already found, 0.927. So the probability to have a non-qualified person given that is approved is equal to 1, the probability for the entire space, minus the probability of being qualified given that it is approved. And the answer for that is 0.0727.